Have you ever looked at a website and thought, how would a hacker even know where to start? Or installed a security tool, pressed enter, and suddenly your terminal started producing so much information that you wondered if your laptop had developed a personality? Here's the funny part. Professional security researchers don't randomly attack everything they see. They follow a process: observe, investigate, test, verify, and document. And today we're going behind the scenes to understand how hackers and ethical security professionals find vulnerabilities, using practical examples that you can safely reproduce inside your own cybersecurity lab. If you enjoy cybersecurity, ethical hacking, Linux, and practical security education, smash that like button. Comment. Which area of vulnerability testing do you want to learn first? Websites, networks, or applications? And subscribe, because this channel is all about helping you develop real cybersecurity skills responsibly. First, what is a vulnerability? Before searching for vulnerabilities, you need to understand what you're actually looking for. A vulnerability is a weakness in a system that could potentially be abused to violate security. That weakness could exist because of outdated software, poor configuration, weak authentication, insecure permissions, exposed services, vulnerable code, improper input handling. Here's an important distinction. A vulnerability doesn't automatically mean someone has been hacked. Think of it like a broken lock on a building. The broken lock is the weakness. Whether someone discovers and abuses it is a separate question. That's why ethical hackers look for weaknesses before criminals can exploit them. Step 1. Reconnaissance. The first stage is usually information gathering. Professionals want to understand the environment before testing it. For an authorized target, they might identify what technologies are being used, what services are exposed, what applications exist, what domains belong to the organization, what operating systems are involved. The key idea is simple. You can't properly test what you don't understand. In a legal lab, you can practice reconnaissance against machines you own or intentionally vulnerable training environments. This teaches you how attackers build a picture of their target and how defenders can reduce unnecessary exposure. Step 2. Enumeration. Now things become more interesting. Finding a server is only the beginning. Security professionals need to understand what that server is actually running. For example, is there a web service? Is there an SSH service? Is a database exposed? Are unnecessary services running? This process is called enumeration. A popular tool for authorized network assessment is Nmap. In your own lab, Nmap can help you understand which services are exposed and whether your machine has more attack surface than you expected. The important lesson isn't memorizing commands, it's understanding what the results mean. Step 3. Identify software versions. Here's where vulnerability research becomes more precise. Suppose a security assessment identifies an application and its version. The security professional can compare that information against trusted vulnerability databases and vendor advisories. Why does the version matter? Because software changes over time. A particular version may contain a known security weakness that was fixed in a later release. This is why patch management is such an important defensive practice. The attacker asks, is this software vulnerable? The defender asks, why are we still running a vulnerable version? Same information, different objective. Step 4. Look for misconfiguration. Not every vulnerability comes from broken code. Sometimes the software is perfectly fine. The configuration is the problem. Examples include unnecessary services, excessive permissions, default credentials, publicly exposed administrative interfaces, poorly configured cloud storage, weak security settings. This is one reason cybersecurity professionals spend so much time reviewing configurations. A perfectly written application can still become dangerous when deployed incorrectly. Step 5. Test web applications. Web applications are another major area of vulnerability research. Ethical testers examine how an application handles login requests, user input, sessions, access controls, file uploads, APIs, database interactions. Tools such as Burp Suite and OWASP ZAP can help security professionals inspect and analyze web traffic inside authorized environments. For beginners, the safest way to practice is with deliberately vulnerable applications designed for training. Never test a website simply because you found it online. Authorization comes first. If you're building a practical cybersecurity lab, one of the best investments is learning material that explains the fundamentals rather than simply giving you a list of tools. I've placed a recommended ethical hacking cybersecurity book in the Amazon section of my description. It can help you understand networking, reconnaissance, vulnerabilities, and defensive security concepts more deeply. The Amazon link is in the description. If you purchase through my affiliate link, I may receive a small commission at no additional cost to you. Let's see if you're thinking like a security professional. Imagine you discover a server in your own lab with an unnecessary service running. What should you do? A. Immediately attack it. B. Ignore it. C. Identify why it's running and determine whether it needs to be exposed. D. Delete the entire server. The best answer is C. Security testing isn't about destroying systems. It's about understanding risk and reducing it. If you're still watching, comment, find the weakness because we're only getting started. Step 6. Validate the finding. Finding something suspicious doesn't automatically mean you've discovered a real vulnerability. Professionals verify their findings carefully. Why? Because security tools can produce false positives. A scanner might report a potential weakness, but further investigation may show that the system is already protected. In an authorized lab, the goal is to safely confirm whether the suspected weakness actually exists without causing damage. This is where professional judgment becomes extremely important. Step 7. Check access controls. One of the most important questions security testers ask is, who is allowed to access this? Imagine a normal user account suddenly being able to access information intended for an administrator. That's a serious security problem. Ethical hackers test whether applications properly separate different levels of access. They examine areas such as user permissions, administrative functions, protected resources, API authorization, account roles. Strong authentication isn't enough if authorization is poorly designed. Step 8. Prioritize the risk. Not every vulnerability deserves the same level of urgency. A minor information leak isn't necessarily as dangerous as a weakness that could expose sensitive customer information. Security teams consider factors such as impact, likelihood, exposure, ease of exploitation. This helps organizations focus their resources on the problems that matter most. A professional security report doesn't simply say, "This is vulnerable." It explains what is vulnerable, why it matters, how serious it is, and how to fix it. Step 9. Document everything. Here's a part of ethical hacking that beginners often underestimate. Documentation. A professional assessment should record what was tested, what was discovered, evidence supporting the finding, potential impact, recommended remediation. Good documentation allows developers and administrators to understand the problem and fix it properly. Cybersecurity isn't just technical skill, it's also communication. Step 10. Fix and retest. Finding the vulnerability isn't the finish line. Fixing it is. Once the organization applies a security patch, changes a configuration, or modifies vulnerable code, security professionals can retest the affected area. The goal is simple. Is the weakness actually gone? This creates an important security cycle. Discover, validate, fix, retest, monitor. That's how vulnerability management becomes an ongoing process rather than a one-time activity. If you're ready to practice these concepts systematically, I've also included a beginner-friendly ethical hacking and cybersecurity course on Udemy in the description. It's useful for learning networking, Linux security fundamentals, vulnerability assessment, and ethical testing through structured lessons. The Udemy link is in the description. Use a legal training lab when practicing and never scan or test systems without permission. Here's the biggest thing I want you to remember. Hackers don't find vulnerabilities by simply pressing a button. They observe, they investigate, they understand technology, they identify weaknesses, they verify evidence, and professionals use that knowledge to make systems safer. If you want to become an ethical hacker, don't focus only on learning tools. Learn why vulnerabilities exist. Build a safe lab. Practice consistently. study real security concepts, and always respect authorization. If this video helped you understand how vulnerability discovery works, smash that like button, comment. Which stage would you like me to break down in a future practical lab? Subscribe for more cybersecurity ethical hacking videos. And remember to check the Amazon and Udemy resources linked in the description if you want to continue learning. Stay curious, stay ethical, stay secure. I'll see you in the next cybersecurity lesson.